first voyage to another world, as it's our closest neighbor, and the journey takes just a few days.
Coming up on pitchover, date. 64, date. Van LPD. 5,000 feet, 39.
The 12 Apollo astronauts who walked across the lunar surface collected rock samples that helped us discover that the moon formed from Earth itself during a collision with an object the size of Mars 4.5 billion years ago.
Minus 6% fuel. Airspace -1. Airspace -1. Contact. Okay, Houston, the Falcon is on the plane at Hadley.
Looking at the moon on a clear night, you can see darker patches that are ancient lava flows, telling us the moon was once volcanically active, just like Earth. But those days are long gone. The craters littered across the lunar surface are the scars of impacts made by comets and asteroids over billions of years. They show us it's been a long time since the moon was a dynamic world. I'm Lupita Nyong'o, and today we're on a mission to explore worlds beyond Earth, to find out if Earth is unique in the solar system, or if there are other active, thriving, even habitable worlds out there. While humans haven't physically traveled farther than the moon, for decades we've been launching spacecraft to investigate the giant disk of objects orbiting the sun. These robotic explorers are programmed to gather and send data back to Earth, allowing us to experience the wonder of these distant places from the safety of our home. The planets closest to the sun were forged of rock and metal. Mercury, Venus, Earth, and Mars. The asteroid belt contains millions of rocky remnants from the formation of the planets. Despite their number, if you squeezed all the asteroids into one object, it would have a mass less than our moon. These asteroids mark the boundary between the inner and outer solar system. Our largest worlds sit on the cold side of the asteroid belt. They have no solid surfaces. Jupiter, Saturn, Uranus, and Neptune. Past the orbits of the planets, we enter the Kuiper Belt, home to millions of icy relics from the early solar system. Some will be knocked out of their orbits and become comets as they dive close to the sun. But the largest among them are frozen worlds, including the dwarf planet Pluto. The outermost region of the solar system is the mysterious Oort cloud, with trillions of icy objects that are barely held by the gravity of the distant sun. Gravity, which holds our solar system together, also ignited its birth. $4.5 billion years ago, gravity caused a giant interstellar cloud of gas, ice, and dust to collapse in on itself. A star, our sun, was forged in the center, surrounded by a swirling disk of debris. Within this disk, a diverse set of objects formed: the planets, moons, comets, and asteroids that populate our solar system. Jupiter simulation shows how young planets formed by gathering up material and carving out their orbits. This theory of how our solar system came to be is supported by observations of a similar process happening today in the rings that form a disk around Saturn. Saturn is the second largest planet in our solar system. It's surrounded by a large family of moons, with even more on the way. But others could develop into unique worlds for future explorers to discover. Like Titan. Titan is Saturn's largest moon, bigger than the planet Mercury. On its grand tour of the outer solar system, the Voyager 1 spacecraft flew by Titan to discover a much thicker atmosphere than expected. A clue to the existence of an active world below. We were eager to see what lay beneath. So decades later, we equipped the Cassini spacecraft with radar vision and the Huygens lander. Titan's surface was a shocking contrast to our own moon's cratered terrain. Huygens beamed home images that virtually transported us to an almost Earth-like world, 1.4 billion kilometers away. Huygens found an active surface carved by wind and rain. But Titan is far too cold for liquid water, so rain here is made of methane, natural gas condensed to liquid, which evaporates from the surface to form clouds, just like water does on Earth. We were surprised to discover a moon so unlike our own, but nearly every mission we've launched into space has uncovered something unexpected, including secrets buried deep inside these alien worlds. Take Saturn's neighbor, Jupiter, a planet with a mass greater than all the others combined, with its own large family of moons. Scientists discovered that as these moons orbit Jupiter, they perform a rhythmic gravitational dance, pulling and tugging at one another. The interior of colorful Io is squashed and stretched by these forces, just as the tug of Earth's moon causes our ocean tides. The result is explosive. Heat from friction melts rocks inside Io, causing eruptions of lava plumes from the frosty surface. Io is the most volcanically active object in the solar system, an amazing world of fire and ice. The effects of an active interior can extend well beyond a world's surface. The Galileo spacecraft mapped a giant invisible magnetic field around Jupiter. This magnetic field is generated by Jupiter's hot insides, where liquid metallic hydrogen churns around the planet's core. Galileo also detected how the moon Europa distorts this magnetic field, revealing another Jupiter family secret. A salty, liquid ocean beneath Europa's icy crust. This alien sea contains more liquid water than in all the oceans on Earth. We found many more Earth-like features out here on the cold side of the asteroid belt than most scientists predicted. Now, let's take a look closer to home. To get there, we'll have to fly to the warm side of the asteroid belt. Just like comets do when they get diverted out of their distant orbits. The Rosetta spacecraft took 10 years to chase down its target, Comet 67P, a frozen object just a few kilometers in size. As Rosetta closed in, its instruments went to work analyzing the comet, finding not only frozen water and rock dust, but organic matter, including amino acids, the basic building blocks of life. Months later, as the comet got closer to the sun, Rosetta saw how 67P's ice was heated and transformed into gas that streamed off into space, carrying organic matter and dust grains with it. We've seen the craters that comets like this one made on the surface of the moon. Comets have also collided with Earth and all the other planets, delivering potentially life-giving ingredients to these worlds. But for these ingredients to nurture life, they need to be held in the right conditions, somewhere not too hot and not too cold, where liquid water is abundant. We find this environment in the Goldilocks zone, nestled between Mercury, which is too hot, and the asteroid belt, where temperatures drop too low. It includes Venus, Earth, and Mars. Our closest planetary neighbor, Venus, is a similar size to Earth and made of the same materials. We could almost call it Earth's twin, yet in many ways it couldn't be more different. Venus's slow rotation and the structure of its interior prevents the planet from generating a magnetic field. Without one, Venus is blasted by solar wind, which over billions of years has stripped the planet of its water, allowing carbon dioxide to build up in its atmosphere. Equipped with radar vision, the Magellan spacecraft peered through Venus's thick haze. It found a world strewn with volcanoes, capable of feeding the atmosphere with water vapor and other gases. But all the carbon dioxide built up in its atmosphere trapped heat from the sun, turning Venus into a greenhouse world with a surface hot enough to melt lead. Going to Venus deepened our understanding of global warming. It showed us that pumping carbon dioxide into our own atmosphere leads to rising temperatures and threatens life on Earth. Unlike Venus, freezing cold. We know a lot about Mars because we've sent dozens of orbiters, landers, and rovers to explore its atmosphere and surface. Mars has the largest volcanoes in the solar system. Long ago, volcanic eruptions generated a thick atmosphere. Mars also has the deepest and longest canyons. Layers of sediments within them show us a record of dramatic climate change. Our missions have also shown us that Mars once held underground aquifers of liquid water. Catastrophic flooding